All right. Okay, got the sound going. Good morning, everyone. Yes, glad you're all here. I'm really excited to be here, to be in Australia, actually. It's my very first time visiting this country and being on this side. I actually expected, like, kangaroos to be hopping by and everyone to say, "Good day, mate," but I guess that's just an American stereotype, so it actually hasn't happened. I haven't seen one kangaroo yet. But if you're new to React, you might hear that on top of just learning React, you have to learn ES Next, and you have to learn Redux, and you have to learn inline styles and server rendering and all these other things on top of just learning React, the library. And it can be kind of overwhelming. And then React is just a UI library, right? So you need to pick libraries for data fetching, or you have to pick a library for data management, or you have to pick a library for how you're going to do server rendering, for instance. There's so many different decisions that you have to make. And if you're just learning React, like, how do you make those decisions if you don't even know what they are and what the options are? So how can you pick what you need? So what I'm going to do is kind of walk through the planets that's surrounding the React solar system and talk about the different things that you need to know, but kind of in the order that you can prioritize them so that you can focus on, I guess, more important things first, and then what I believe to be less important things afterwards. And then within those categories, I'll try to highlight a couple of different options, different libraries that are in this space, and then what I believe to be the best option or the most popular option, basically what my preference is. But first, if I can get everyone to stand up with me, So it's early in the morning, right? And you guys are a little tired, right? And I like to exercise the mind with my talks, but also exercise your bodies. So what I want to do is we're going to do 10 squats just like that, okay? All together in unison. It'll be tons of fun. And if you don't want to do it, that's fine. Or if you can't do it, you can just do your arms. That's fine too. There's no like obligation. The idea is just to be fun, but just to get the blood flowing to get started, so it like will reduce the likelihood of you falling asleep during my talk. Okay? All right. So we'll do it all together. Here we go. 1. Yep. There we go. 2. Looking great. 3. Okay, 4, keep going, nice. 5, oh yeah, this is great. 6, 7, almost there. 8, 9, and 10. Nicely done, nicely done. Wait, before you sit down, turn to your neighbor, introduce yourself, and say hello. Great. Awesome. Okay. So now you've all met each other. I wanted to formally introduce myself. My name is Ilegbodu. I'm a Christian, a husband, and a father. This is my wife, Rashida. We've been married 8 years. We just celebrated our 8-year anniversary 2 weeks ago. This picture was actually taken in Madrid, Spain. 2 weeks ago. And then those are my our two daughters, Simone and Avery. Simone is the older one. She's 4.5. She's the one next to me. And then her younger sister, Avery, is 2 years old. And then actually my wife is pregnant right now. So we're expecting our third child due in mid-January. So excited about that. We don't know if it's going to be a boy or a girl yet. We actually got the results. It's in an envelope that's sitting on a kitchen counter, but we're going to have a party when I get back, a gender reveal party to figure out if it's going to be a boy or a girl. I'm not sure which one I want, but yeah, excited for that as well. So we live in a town outside of San Francisco, so San Francisco Bay Area. It's kind of expensive to live in San Francisco, so we live a little bit outside of it. And I work for a company called Eventbrite. Hopefully, maybe you've heard of them before. You should have, since you bought your tickets to come here on Eventbrite. Hopefully you paid attention to realized who you were giving money to, but that's all right. I work on the front-end platform team. So I'm a principal front-end engineer on that team. So we don't focus on actual end user features, but instead we're on the front end, the entire front end platform. So we work on the front end infrastructure, so things like Webpack and Babel, which I'll be talking about a little bit later, as well as our component library or design system that's in React as well. So we transitioned from Backbone over to React maybe 2.5 years ago. That's when we began it, the beginning of 2016, and then kind of haven't looked back from Backbone and been working in React. I'm originally also from Houston, Texas, and I absolutely love basketball, playing and watching. So my favorite team is the Houston Rockets. There are a number of Aussies in the NBA, Andrew Bogut being one of the bigger ones, physically as well as skill-wise. But yes, love the NBA. So enough about me though. Let's talk about this React solar system. So I'm going to be covering a whole bunch of things in this talk. And I wanted to let you know that I tweeted out a link to the slides. So if you find things that you in the slides that you're interested in, you can just go to my Twitter account. It's just @BenMVP, and you will find the links there, so you don't have to worry about not having access to them. It's already there for you. But wanted to ask you all, so who considers themselves to be like React newbies? Who feels like they're a React newbie? Okay, so like most of the people in here, great. Glad you're here. I'm going to introduce a whole lot of things to you, so hopefully there'll be a lot of things that you learn about. So at the center of this React solar system obviously is the sun. That's React. So let's talk a little bit about React. So when you're getting into React, the first thing I suggest is that you learn React, right? And that's kind of obvious, but learn React really, really well, and just React by itself. Because even within React, the library, there's a lot to learn, right? So React is highly functional, and it's reactive with a unidirectional data flow. Like, those are a whole bunch of big keywords. And if you're used to the MVC model with like Angular or your backend technology, it'll take time to like wrap your head around these concepts and how React works a little bit differently than what you may have been used to. And then of course there's the JSX syntax, which is different in that you're putting your markup inside of JavaScript, which we'll look at in a little bit. And you have to make sure that you're leveraging something called the virtual DOM, or the real word is the reconciler. And that allows us to not directly manipulate the DOM, but let React handle that for us in an optimized way. But thankfully, the API of React is actually really small. You can actually keep it all in your head, which is pretty nice. But you're able to create, I believe, great user interfaces just by using React. You don't have to add in all the additional libraries. You could just use JSX and React. So imperative, for simple tasks, imperative code is actually pretty easy to follow, right? So we have here this button, and when I click on it like this, it just increments the value that's in that text field. So pretty straightforward there. The jQuery for this is that we have a jQuery handler on the button, and then we wire a click handler on it. And then inside of it, we get a variable to the input, and then we parse the value out of that input, and then add the new value by incrementing that value. So it's pretty straightforward in how that works, but as we know, as things get bigger and more complicated, this code, this imperative style can get pretty crazy. You know, we call it jQuery soup affectionately. So switching, the same implementation here in React looks a little bit different, right? It looks a little bit more complicated on the surface. So let's take a look at how the code works. So as you may just notice off the bat, is that we're including the markup inside of the JavaScript, which is different than most of the other languages. And basically with React, your UI is a function of your state. So you kind of just declare, this is what my UI looks like when the values of state are props as well. So first we initialize the state here at the top with a value of 0. So that's going to be the initial value of our input field there. And then inside of the render method, which is where you declare your UI, we just initialize the input field, its default value to be the value of this dot state, right? And since the initial value was 0, the initial value of the input field will be 0 as well. And then we go ahead and we click the button, and the button has a specific on-click handler on it, which is a reference to a function called handle click. So instead of like having that separation of the markup and then wiring an event, we actually put the event right there on the button. And then once you click, you go into handle click, and then there's this method called set state. And set state is what updates the internal state of the component. And we're just updating the state to be the previous value plus 1, and then we're setting it. And the thing about React is that when you set state, it calls render again with a new value of state, and then now the value will be 1. And then you just have that loop happening over and over and over again, and that's how you build interactivity into React. And it may look like, when we call render again, that we're going to re-render the entire UI over again, but React has what I mentioned before, the virtual DOM or the reconciler, which will tell that, oh, you know what, that div never changed, that button never changed, and actually the only thing that changed in the input was the value. So that's the only micro change that I'll make to the DOM. And React handles that on our behalf instead of us having to maintain it or manage it ourselves. So that's kind of the real kind of developer experience benefit that we get by using React. So for this most basic example of interactivity, it's more complicated, like not gonna pretend or gloss over it. Like it's definitely something that's harder to understand because of the unidirectional flow. But as the UI gets more complicated, more sophisticated, React, I believe, scales much better than the previous example that we saw. So unfortunately, I don't have time to like go into more about React and teach React. That's not the purpose of this talk. But the React docs have a great intro tutorial where you build a kind of simple game, and they go through all the concepts of React. So you can totally check that out. I've also built what I call the React Fundamentals workshop, where it's a step-by-step workshop where you can learn different concepts about React while building a fake email app. So you can check that out as well. But both tutorials, the React intro as well as my workshop, are written in what's in ES Next or ES6 and beyond. So I find that it's pretty important to actually know that and learn that as well. So in my opinion, React is even easier to write with ES Next or modern JavaScript. So outside of the JSX syntax, React is actually just JavaScript. And even that JSX syntax gets transpiled to just JavaScript. So really all of React is just JavaScript. So learning ES Next makes writing React a lot easier. So chances are, if you're going to learn React, you're probably going to see a lot of modern JavaScript as well, some new ES Next concepts. So here are a couple of them, modules and classes. So modules are for separating our files, classes help declare our components, the spread operator helps copy arrays and objects pretty quickly. So hopefully, likely you've been using some of these already, even in your current your current JS framework of choice, but in React they're used very heavily as well. So similarly, I don't have time to go into those and go deep dive into those features, but I gave a talk at React Conf last year called React plus ES Next is Love, because they really go together really well. And you can take a look at that, and I took a couple of the features that go really well together, and you can watch that video. And lastly, here are some other resources for you. So I wrote a whole blog series on ES features that you can take a look at, and Eventbrite. We also have a coding style guide around ES Great. So let's jump into the first planet, Mercury, talk about tooling. So the first tool I want to take a look at is the React Dev Tools. So let's start a little easy. The Dev Tools is an extension in Firefox or in Chrome that allows you to debug your React applications. So you can take a look at the props, you can inspect the state, so you can actually see what is going on in the React component as it's being rendered and watch it change over time. And you just see the component hierarchy just like you would see the DOM tree in the elements inspector as well. So it's not available for Edge, so I'm sorry for those who develop in Edge for more reasons than just this. No, actually Edge is a great browser, so it's not like IE anymore. But also the latest version of React, actually 16.5.0, just has a release of some new debugging features for performance. So you can actually now see where the bottlenecks in your components are, which is pretty cool as well. So you get a whole flame chart and see, oh, this component took too long to render, this was doing something that it shouldn't be. So it's really helpful, the dev tools. Then there are package managers with React. The main ones are npm and Yarn. npm actually is the repository of all of the dependencies, and Yarn is just a kind of layer on top with its CLI to interact with that. So more or less now they do the same thing. When Yarn first came on the scenes, npm was kind of resting on its coattails, I guess, something like that. So Yarn really pushed the boundaries about what it could do. I currently use Yarn. It's built by Facebook, but considering actually switching back to npm, mainly because Facebook no longer has a team dedicated to continuing to advance the feature set there. But inside Yarn, there was a whole lot of great features, and it kind of changed the game of what dependencies management should look like. So it has this flat mode for dependencies, so that if there are multiple different packages that have the same dependencies, they get rolled up to the top, so you don't have all these duplications of files on your file system. Has this offline mode, so once you have installed for one time, it's like cached locally, so you could in theory be on an airplane and do a Yarn install and actually have everything be installed, which is pretty cool. It's deterministic, so it has this lock file. npm has a lock file as well, but has a lock file, so if you install on your machine and you install on somebody else's machine and you install on the CI server, like they all have the same installations, which seems like logical, but wasn't the case before. And also network resilience in that it will retry if installations fail and such. So then switching on, we can talk about bundlers. So there are a number of players in this space. Webpack is the main one that's there right now. Rollup specifically works with ES6 modules, and it introduced this concept of tree shaking, which I'll show in a little bit, which is pretty cool. Rollup is mainly for, I guess, component libraries, because it's mainly used to transform files into, transpile files into maybe ES5 versions of themselves, whereas Webpack is used for taking multiple files and bundling them together. Prepack is basically kind of like Webpack, but built by Facebook. It's something that they just created right now, and it tries to do all these optimizations at compile time instead of having to do them at runtime, so it can be faster, but it's still in kind of early development stage, so it's not quite yet ready for production. And I put require.js on here specifically just to call out not to use it. We were using it at Eventbrite when we switched over to React, and it was just a nightmare to deal with because it's not set up to be used in kind of a modern system and whatnot. So I would say use Webpack if you're having to decide and having to pick someone. It's still currently in active development. It's always evolving, so it's great in that regard. So speaking of tree shaking, the way that it works is that if you have this module, let's call it maths.js, it has a square function, it has a cube function, and then in your main JS file, you import just cube and use it. The resulting bundle will just have cube in your code. It won't include square because that was never included. So whereas before, the kind of naive bundlers will just include all the files together. So if you're maybe using something like Lodash and using its module version, if you're only using one function out of there, then you can have a much smaller bundle than if it included everything. So that's pretty cool. And now a lot of the modern bundlers use that. So then there's task runners like gulp and grunt, and then npm scripts as well. So grunt was the big thing in the beginning, but then the grunt files got crazy to maintain, so gulp tried to come in and make a new way to use it, using streams in a functional way. But then we started getting kind of like task fatigue and having to run all these things. So a lot of people just use what are called npm scripts. So just scripts in your npm, in your package.json. And those just basically wrap command line arguments. So if you take a look at what that looks like, maybe you have a start script, a build script that call webpack. You have a validate script like we have at the bottom, yarn run validate. Then that will call yarn run lint and yarn test. And then if you look at lint calls sasslint and eslint. And then if you look at eslint, that actually is what calls the actual command for eslint. So it's a way to kind of organize things a little bit more simply than with using grunt or gulp. But if you had something that had maybe 30 scripts in there and they're all doing some sorts of kind of generation of files, you may want to move into using gulp. So actually, speaking of linting, there's also static analyzers. So there's ESLint, there's Flow, there's TypeScript. And ESLint was originally used just for kind of fixing your code, or for people having a consistent way of writing code. But now it can actually catch common errors, especially, or in addition, in React as well. So issues with your JavaScript or with your JSX, and common pitfalls with React. And Flow and TypeScript, they're mainly just around static type checking. So JavaScript doesn't have static typing, but they added on top of it. Flow is just for static typing, whereas TypeScript is static typing plus a JavaScript superset, so it does transpilation as well. TypeScript actually included JavaScript classes before they were introduced into real JavaScript. And it also has things like interfaces and other types of systems, or I guess types that you would see like in C# and things like that. So I've used Flow before. I haven't really liked it because I found myself developing and fixing Flow instead of developing and fixing my app. And I'm kind of leaning towards TypeScript now. I used to do a lot of C# development, so it kind of feels similar to that. And it just seems to be better at typing, in my opinion. But it is more all-in than Flow. So with Flow, you can just kind of ease your way into typing this way. You add this directive at the top of your file, / or comment, and then just have @flow. And then all of a sudden, it just starts typing your file. So without even changing your code, it can start giving you helpful feedback. Like in this case, I'm passing a string when the function is going to do multiplication on a number. And obviously, it can't do that. So it'll give me, it knows that x inside of the foo function is going to be a number, has to be a number, and gives an error that way. Okay, so that's everything you need basically to bootstrap a React app. All those things that I listed, right? And I didn't even go into the nitty-gritty details of them all. And that had always been the biggest complaint about React, like all the effort you needed to bootstrap an app when all you wanted to do was just like get a hello world going. So the people at Facebook created a team around it, and they created this system called Create React App that allows you to bootstrap an app super quick with zero configuration. And if you need to do some configuration, then you just eject from it, and then you can have your own setup. So here, using this helpful library called npx, which actually comes from npm. It's a way to quickly install a global shell script without having to actually install it globally. So it runs it one time, temporarily installs it, and then removes it after the installation, which is pretty sweet. So you say npx create React app, the name of the app. I called it awesome app. And then you go into that folder that was just created, and you start it using the npm scripts, yarn start, and then bam, you have your app, and you can start building your components instead of having to do all the other development there. And it has a build script that allows it to create an optimized bundle for it to go into production. So it handles that part for you. So here are a whole bunch of resources around tooling. If any of those things you wanted to take a look at, feel free, have all those links there. Great. Okay, so now let's jump into styling, which is kind of a big issue in React as well. And I can think of maybe 5 or so ways, at least 5 or so ways to tackle styling in React. So we're looking at the planet Venus now, the second planet from the sun. So the first is global CSS. So likely if you're transitioning to React from something else, you likely already have a CSS solution in place. You're already creating something that's bundling your CSS together. So you have this global CSS that you can just refer to inside of your components. So you'll just create new React components and then reference those CSS classes. So if you're using something like Bootstrap, you're using something like Foundation, this would fall under that as well. And you just include those classes there. And you need to make sure that your classes are properly namespaced, right? So that you don't have namespace collisions. So you can use something like BIM or SMAX or object-oriented CSS to make sure that your classes don't collide. So then, instead, you can use something what I call component CSS. This doesn't really have a name, but I've given it this name, where you import the CSS, and that's all. There's no variable or reference, you just import it. So it's a lot like global CSS, but instead, it only imports the CSS that are being used. So if the component is never imported, then the CSS is never imported, and you don't have too much unused CSS. But the code is written the exact same way. And your CSS is basically written the same way, except that you now put all the CSS in separate files. And likely, if you were doing your CSS right before, you already had them componentized, so it shouldn't be too much different than before. So the transition shouldn't be too bad. Okay, and then there's CSS modules, which is like the next step after that. So it's similar to component CSS, except this time you actually are importing this object. I'm calling it CSS in this example, and it's a lookup of auto-generated class names for you. So you import CSS, and then you assign to the class name property CSS dot whatever. And then in your CSS module file, you no longer have to namespace yourself. Like you can just use whatever classes for you, and the CSS modules library will namespace the classes for you. Just name it, the classes, whatever you want, and then they get auto-generated just like that. So they use whatever heuristic and encoding to make sure that the classes are guaranteed to not collide with anything else. Then there are people who are just like, you know what, screw CSS, right? I'm tired of the cascade and all that stuff. I don't know what's going to happen. So I'm just going to go old school and just put everything inline. So inline CSS, there's no way there's going to be namespace collisions. There's no way I'm going to have cascading issues, and just put everything inline. And there was a huge push for this, actually, because of React Native and people wanting to share components between React and React Native, because React Native doesn't support CSS, just only inline styles there. So this is a way to accomplish it. So you import this module that you define yourself. So we're calling it styles here, and then you just set them on the style property. So style.root or whatever. And then your object will look something like this. So instead of using kebab case like we're normally used to for CSS, you use camel case because that's how the style object on the DOM works. So flex direction, for instance, is camel case instead of flex hyphen direction. But the problem with inline styles is that they only support what inline styles support. So you can't do media queries, which are really important, obviously, for responsive design. You can't do pseudo selectors. You can't do keyframe animations. Like, none of those work. So people wanted the expressiveness of CSS, but the kind of encapsulation of inline styles, and they started creating the CSS and JS revolution, I guess I'll call it. And it takes kind of the best of both worlds. So here we have emotion, we have JSS, we have radium, and we have styled components. So the two main ones, the kind of leaders of the pack, are styled components and emotion. I lean more towards emotion because it can do everything that styled components can do, plus more in terms of how you can define the CSS. So emotion is the newest one of the four, so it's kind of taken what all the other ones have done and done more on top of it. So if we look at a little quick example of how emotion works, you basically create custom components with the styling of the DOM that you want. So for instance, the title component, for instance, that third line is a styled H2, and it has a font weight of bold. And then now you use that component that you just created down in the markup, and you have your title that way, and you put all your styles that way. So the styles don't have to be inline in there. You can put them in a separate module if you want, but that's basically how the API works. But it supports like the full range of CSS syntax. So you can do media queries, keyframe animations, pseudo selectors, and so forth. So it has a lot of support. And there's also theming support as well. So you can do themes, which are pretty cool. And we've been really recently looking into it at Eventbrite, specifically for the theming option. And then what the markup ends up looking like is something like this. It'll auto-generate CSS classes. So in the end, it creates CSS, but it creates it for you, and you don't have to worry about it. It just looks like inline styles for you. So have a bunch of resources there for styling as well. So React CSS modules, there's different component libraries, Material UI, React and Foundation, React Bootstrap if you just don't want to have to create one yourself, and a bunch of other helper libraries. Okay, so now, next planet, planet Earth, third planet. From the sun, let's talk about single page apps and all the libraries there. So, kind of your favorite kind of walled garden JS framework, like Angular, where you're just like all in, provides a mechanism for Ajax for you, right? So if you're using this library, there's already a way to just make an API request. But React is just the UI library, so it doesn't come with anything like that. So the second you want to make an API request, you now have a decision to make, like, how am I going to do this? What am I going to use? And you could use jQuery, right? But that could lead you to doing other things that with jQuery that you probably shouldn't be doing with React. So instead, the common practice with the React is to use the native Ajax implementation in the browser called the fetch API. So you do window.fetch, or just leave off the window and just call fetch. And it works with ES6 or ES 2015 promises. So it looks very similar to jQuery Ajax, but you just say fetch, and then you get back a promise, and then you do then on it, and then you will get the response with the data that you want, or you can catch any errors that happen. And now the benefit of fetch using promises is that as promises evolve and become better, the fetch API will become better. So we're adding in, they're adding in to promises, or just landed finally in promises, so you can do something as cleanup. So that will be available at Fetch as well. So if you're wanting to learn more about Fetch, here are some articles on how that works. In my workshop, I have a whole step on how to use Fetch, so you can learn that way. And then with single page apps, there's also routing that has to happen in order to keep your UI in sync with your URL and vice versa. So React Router is the main one. It's the one that's been around since basically the beginning. It's now in version 4. And actually version 4 was a complete API change from version 3 to make it more like React-y. And it's the most in prevalent use. But there was a lot of things that were lost from version 3 to version 4. So the creator of React Router kind of just created a whole different router called Reach Router. And the idea is that it's supposed to take the benefits, or the nice things from version 3, the nice things from version 4, and put it together. But it was intended to be accessible by default. So when you're navigating to different routes, it'll automatically add focus to the changed part of the page instead of you having to maintain it yourself, which is something that React Router didn't do and most other routers don't do for accessibility, so that the person who's using a screen reader knows what part of the page has been changed. And then also it comes with this kind of fancy ambiguous path ranking algorithm. So if there are two paths, or if there's a URL that could match two different paths, instead of just picking the first one, it has this algorithm for figuring out which is the best one. You can use relative links inside of your URLs. It has like not found default components. So if there is a URL that doesn't match any paths, it can fall back to. So I also don't think there's active development happening on React Router anymore. So I haven't used Reach Router yet, but next time I need a router, I'm going to go that way. So looking at it real quick, if you've ever seen React Router, this is kind of very different. Reach Router is. So you have in your app, you have a router component, and then within it, you just have your normal child components like normal. You just add a path parameter to them, path prop rather, and the router reads that and knows which component to show in different cases. And then there's a special link component that you use to make your links that basically wraps an A tag for you there. Cool. Okay, so forms. Forms are hard, right? And forms are hard because validation is hard. And in React, unfortunately, it's no different. And forms are hard because the requirements are always different, right? With the form, you can have form level errors at the top. You can have form element level errors within each field. You can have synchronous validation that happens because with like regular expressions. You can have async validation when you need to make an API call to see if this user is in the system. You can have validation that depends on multiple fields and whether or not there's an error. You can have errors that show immediately after you leave a field because you want to let them know that emails are in use or that username's in use. But you can have errors that wait until you click the submit button because you don't want to shout at them right at the beginning. Like there's like so many different things you can do with forms, and it makes things really complicated. That the React docs on forms don't talk about any of that validation stuff. They just talk about just like the normal way to maintain state with form elements. So unfortunately, there has to be libraries around forms to maintain form state. And there are three main ones. There are final form, formic, and redux form. Okay, so for the longest, it was just redux form. Like that's all you had, the main one. And as you can tell by the name, it meant that you needed to have redux. So the second you want to have any kind of sophisticated validation in your React app, you now have to add redux. And that comes with a whole host of additional things that you have to learn. And the library was really big. because there were more and more feature requests that were happening. So Eric, the developer of it, decided to do a rebuild instead of, so that it didn't depend on Redux anymore. So he created a final form that had no dependencies and a small footprint to begin with, and works with something called render props in React. So any new features that you want in it, instead of adding it to the library, are now separate plugins so that everybody doesn't have to have it as well. And the nice thing that even though it's a new library, it's battle proven, battle tested, because he made sure it worked with all the different use cases that the Redux form had. And if you go to the docs, there are like 30 plus different examples of different types of forms that you want to do. So it's really, really extensive and has lots of recipes for you. So then, unfortunately though, while Eric was building final form, Jared was building Formic, and they didn't know that they were building the same thing at the same time. And I had a conversation with both of them actually last week. We were both at the same conference, and they both said, like, if I had known that you were building yours, I wouldn't have built mine, right? Because no one wants to build form libraries. They're gnarly. So Jared also wanted a Redux-free implementation, so he created Formic, and basically it's parity with final form. So they basically can do most of the same thing. Just depends on whichever one you want, essentially. Like we've been using Redux form heavily at Eventbrite, so if we're going to switch away from that, we would probably switch to final form because the API is very similar in terms of how you use it. But really, you can't go wrong with either one, and they're both actively developed, so that's really nice. So I have links here to that React docs that I told you, and then a workshop on forms. Okay, so at this point, we're at the asteroid belt of our solar system. So we've talked about React and JavaScript. We've talked about tooling, styling, single page apps, and forms. And actually with this, you can create production level apps and ship and just be fine. Like you don't have to do anything else in the libraries. But I still have more that we can talk about. And this is basically, you start getting to like larger scale apps features that you would want in there. So let's talk about those. So the next one, we're at the planet Jupiter. So let's talk about testing. Like I hate putting testing this far in because I'm really a proponent of testing, but the previous first 5 were definitely more important, unfortunately, than testing. But testing is important. And just like there are many JavaScript frameworks for building user interfaces, there are many JavaScript testing libraries as well. So there's some micro libraries like Mocha and Chai that do specific things. So like Chai is just for assertions, so it gives you expect or it gives you should. And but on the other hand, Jest is like a full-featured framework. It's built on top of Jasmine. It was built by Facebook, and it actually started off really crappy, to be honest. Like it was terrible, and no one used it. But then at some point, I don't know why, they just decided to make it good, and it's been like really awesome since like the last year and a half or so. So Jest is what I use for testing React and for testing anything really. Like it can do everything and does everything really, really well. There's a lot of active development going on in the open source community around it. There's also Ava or Ava, not sure how it's pronounced. There was a lot of initial buzz around it, but I don't really see people using it and testing React, so I'm not sure about it, but it's definitely another option there. So quickly on Jest and Enzyme, this is how we would test. Let's say we had a button, and you can configure the style to be primary or secondary. You know, we always have these with our buttons, right? The main button or the secondary button. So let's say when it's primary, there should be a class on it that says that will style it to be primary. So in this case, when we pass the style equals primary prop, we want to ensure that the class is there. Because when we're testing React components, we basically want to test whatever logic is in the components, but only via its public API. And the public API is basically the markup that's rendered or any callback functions that are called. So we can use this helper library called Enzyme, which is amazing. And basically is a way to render React components without the browser. So we can render it in a testing environment. And it has this like jQuery-like interface for inspecting the components. So you can ask all kinds of questions on it. You can find elements. You can ask if it has a class name. You can simulate clicks or simulate events. Like, it's amazing. Pretty much any environment that tests the React components is going to use Enzyme. Okay, and there's a bunch of testing resources there for you. So, next planet is Saturn. Chances are, if you're building an app of significant size, right, SEO and initial render speed are going to be really, really, really important to you, right? And they're really, really important for us at Eventbrite. Like, SEO is really important for us, and the render page of the speed of the render is really important. So basically, you accomplish that by doing server-side rendering. And this is called like isomorphic React or universal React. And basically React, which is the one awesome thing about React, is that it allows us to use the same components that we render on the client to render on the server. And that provides that initial speed up of the render. So even though Google now can run JavaScript, the initial rendering speed of a page is factored into SEO ranking. So you want it to be as fast as possible. And then in addition to SEO, I just learned this new term called SMO, which is social media optimization. I knew about the topic, I had never heard of the term, and it's basically like when you share something on Twitter or you share something in Slack, you get those previews, right? It has an image, it has a description, it has a title. Like, all of that is generated from the rendered markup, the server-side rendered markup. So though Twitter and Slack are definitely not executing JavaScript on your site, so you definitely want something there server-side generated. So it's pretty important, and React provides a way to do that. So there are a number of different libraries for server-side rendering if that's something that is important to you. There's there's different levels that you can go with. So there's the full framework approach, which Next.js is the best in that regard. It's a minimalist framework for that, but it has built-in routing, has code splitting, has CSS support, data fetching, like everything you need is there. And then on the complete opposite side, there is static site generators. And Gatsby is like far and away the best of the best of the best. So my site, benmvp.com, is actually using Gatsby. And basically it does all the same thing as Next, but just does it at build time or compile time instead of at runtime. So on my machine or on my CI server, I just say build, and it generates all this HTML and CSS and JavaScript for everything, for all the data, for all the files. So I never have to hit a database on the actual site. And it creates a progressive web app for you. So it's offline first, and it does data prefetching. So if I'm on an existing page, like, it'll prefetch the next screen for me. So it's pretty cool. And then there's Razzle, which is kind of in between, which is just a library that has helpers for server-side rendering. And that actually is not specific to React. It can work with Vue, it can work with Angular, it can work with other UI libraries as well. But you have to figure out the routing and the data fetching and such. And then lastly, if you want, which is actually what we do at Eventbrite, unfortunately, is that you can roll your own, essentially, using Express or using Koa or some other node server to do it. So you would use a router like Reach Router. You would do data fetching with a library called Isomorphic Fetch, for instance, which I have a link to at the end, and roll it yourself if your backend is in Node. But if your backend is not in Node, which is Eventbrite's case, our backend is actually in Python and Django. Rendering server-side is a challenge, is more challenging because you have to use JavaScript, you have to use Node in order to render your components server-side, but the backend is not in Node. So we ended up having to set up this system that we would have this kind of internal Node server that's just for rendering components that Django would talk to, and this whole setup. So this is a talk I gave at RenderConf last year that explains how all that works. So here are some more resources. That first one is a link to like a whole bunch of resources about, more resources about server-side rendering. And there's this tool called React Helmet that was created by the NFL, which is pretty cool about how to get, how to render things that need to go in the head of your document, because React is only about rendering things that go in the body. Okay, so almost there. So second to last planet is Uranus, right? Uranus, that's how I'm gonna pronounce it. Someone got it a little bit later. We're going further and further from the center, so it's less and less important. Up until this point, we've been using React to store all of our data in the actual component. So you would have this like God component at the top that stores all the data. But once the structure becomes too complex and you want different parts of the React component hierarchy to know data and to update data, you need a data management system. And the way that's done in React is with the Flux pattern. So if you've ever heard of Flux, you've probably seen this diagram. And if you're like me, the first time you saw the diagram and it was explained to you, it didn't make sense. And then if you're like me, the second time it didn't make sense, and then third time it didn't make sense. It took me really understanding React in order for me to understand Flux better. And that's why I think it's a disservice when people are learning React that they also try to teach them Flux or teach them Redux at the same time, because it's like yet another way to think about how to maintain data. And it takes a while just to understand how it works. So I'm not gonna go into the detail of how it works. It's just basically another unidirectional way to ensure how your data is updating and how to read the data. But it just basically makes the mutations of your data predictable. So there are two main implementations of the Flux pattern that are left that exist. There are plenty in the beginning, but now it's just Redux and MobX. So actually, originally, Eventbrite, we wrote our own Flux implementation using Backbone, which was like the worst idea of the worst ideas. But we switched over to Redux, and it's been much better since then. Redux was created by Dan Abramoff, I believe, is how you say his name. And it's now basically the implementation that most people use. And look, we're talking about Redux here at step 8, not in the beginning. This is when I think it makes most sense to add it to your stack. There's also MobX, which is a different approach to the Flux pattern. So basically, Redux has this concept of reducers, and you never mutate your state. You always make copies of your state and then update those copies, whereas MobX uses observables, and you mutate your state, and then the observables broadcast that a change has happened, and then your UI updates as a result. So they're just basically two different ways to accomplish the same thing. I would suggest using Redux because there's a whole ecosystem just around Redux. But either one works okay. And so then if you're gonna go the Redux route, you need to make sure that you're maintaining immutability in your data. And there are two main ways to do that. Well, three main ways to do that. One is that you can do it yourself with native objects. So anytime you need to add something to an array, for instance, you don't call push, you would use the spread operator or make a copy of it and then add something to it. But if that becomes too difficult or performance becomes an issue, you can use one of the libraries that we have here. So Immutable.js or Seamless Immutable. So Immutable.js comes from Facebook. And Seamless Immutable is another library. Immutable is far and away the big player, but I've actually found the API to be really cumbersome to use. It's very different than the native APIs, whereas Seamless Immutable is much more similar to how JavaScript arrays and JavaScript objects work. So I really like its interfaces. So if we look at Seamless really quick, yeah, basically you just can't mutate the objects. But the nice thing is that it's backwards compatible with arrays and with objects, native arrays and objects. So you can pass it to helper libraries like Lodash or underscore, and they actually work. Whereas with Immutable, you can't do that. Okay, so the last one, API optimization. Planet Neptune. So as your app grows larger, you may find that you're making lots of REST API calls, right? A single action can result in 3 separate API calls. Maybe they're in parallel, but most likely they're sequential, which is bad for performance, but necessary for this whole microservices thing that we've done. So there are some cutting edge technologies that we can use. So Facebook and Netflix basically tackled this exact same problem with different approaches at the same time again. So Facebook came up with GraphQL, so a whole new query language, graph query language, for making API calls. And then Relay and Apollo are 2 different React connectors to GraphQL. So Relay is created by Facebook, and Apollo is created by someone else, not Facebook. And Falcor was created by Netflix, and it has a different data model. It's basically both the server and the client at the same time. From my understanding, Netflix is not really supporting or actively developing on Falcor right now, and there's a whole lot of excitement around GraphQL and a big ecosystem around it. So I would go the GraphQL route, and then Apollo just has a whole lot of active development around it. So that's the client that I would use, is Apollo. But the thing about GraphQL, it makes your clients a whole lot easier to use, like the components you write, but you have to change your server. So you can no longer use your REST APIs. You have to have a GraphQL API. But you can put GraphQL in front of your REST APIs so that you don't have to rewrite everything. So here's a quick look at what Apollo looks like. Basically, your components just declare their data dependencies right there. So instead of having to use Redux, you can just use GraphQL and say, hey, I want this data. And Apollo knows how to join all these different things together to make one efficient request to your GraphQL. So in the end, you may not even need to use Redux anymore because it's managing your data for you, which is kind of cool. And I mentioned Gatsby before. Gatsby uses GraphQL in order to maintain its data. It just does it, once again, at build time, not at runtime. So here are some resources. The how to GraphQL just takes you through like how to GraphQL, basically. And it's pretty cool there. Okay, so quick TLDR in case you missed anything. So you could have just like not been paying attention the whole time, and then now you can pay attention. So number 1 is start off with React and ES Next, right? That's what you want to do. Focus on that. And then number 2, for tooling, just use Create React App. There's no cool logo. I don't know why they didn't create one, but use Create React App. Then if you're doing styling, I would say try out Emotion. Use CSS, global CSS, is that what you got? But then use Emotion. For single page apps, use Reach Router. Give that a try. It seems like it's kind of solving the routing thing really well. For forms, Final Form is a great way to handle sophisticated form validation. Then with testing, use Jest. With Enzyme, of course, for unit testing. Server-side rendering, try out Next. If you're needing to do something really sophisticated at runtime, But if it's a static site, just use Gatsby. And then for data management, Redux. And lastly, for API, use Apollo like we just talked about. So there. But you may have noticed as I was talking, there were a lot of libraries that Facebook has created, right? So here are all the ones that they've created. So obviously React, created Yarn, they created Prepack, Flow, Jest, Redux, GraphQL, as well as Relay. So basically all the things that they've created to solve their problems internally, they've open sourced it. So Facebook, technically it's a social networking company, but it's also an open source company as well, and we're all kind of benefiting from it. So that's basically it. I just flooded you with so much information. Like I said, the slides are online. At the bottom left, there is the link to the slides, bit.ly link, but you can also go to my Twitter account, like I said, and the tweet should be there. Hopefully, one or two or all 9 of the suggestions will prove useful to you. But like I said, don't be overwhelmed with everything I just told you about. Like, just learn one thing at a time and get good at it, and then build upon that knowledge. So, wanted to thank the conference, NDC Sydney, obviously, for inviting me all the way here to share my knowledge with you. But then also wanted to thank all of you for attending the conference and coming here to my talk. There were a number of other options you had, so I appreciate it. I go through the stress of preparing talks and delivering talks, but I do it all, so that I can share with you and hopefully that you can learn. So if there's even one nugget of information that you took from that, then it makes it all worth it. So thank you very much.